Okay, welcome. This is for silver classes for Monday, November 19th. I'm at a math conference all day, so will not be here. This video is for you. The notes are already up on Blackboard as well, so you can follow along on those. Pause this, stop it, right? Whatever you have to do that's going to help you. It will be a fairly decently long video, so I do apologize for that, but we've got 3 pages of notes and not much I can do. All right, first thing, I want you to turn your notes to the back side. I want the blank piece of paper. I want to go over a couple things for you, okay? First thing, we are dealing with inequalities. Okay? Couple things about inequalities I want you to know. First off, you should know this already, but let's just go review it. If I see this symbol, this should be greater than. This is going to be less than. This should be greater than or equal to. So it's greater than or equal to, and last but not least, less than or equal to. Okay, those are our 4 inequality signs. Okay, so reminder that you should have already had that before, but just a quick reminder. Now, it is always greater than if I'm reading left to right. So the other part of this is I want to read an inequality left to right. But more important than left to right, okay, more important than that, is it has to be variable to number. Okay, your variable to your number. What I mean by that is it should always look something like that, okay? We don't want it on this side. Is it correct? Yes. But when we go to graph, it makes it much more difficult. So we always want our variable on the left-hand side, never on the right. This is still x is greater than 5. This is x is greater than 5. They're both the same because I read it variable to number. I want to read it left to right, which is from here to here. But more importantly is I read variable to number. So x is greater than 5. Okay? So that's one big key part of this. The other part, and let me erase this so I can get some room. The other part of this is there's a big rule that I know you haven't gotten since I've taught blue class already. I know this. I know we don't know about flipping the inequality sign, so I'm going to go over it real quick, okay? And that is, if I have negative 3x is greater than 15. Well, this is an equal sign. If this is just an equation, then I know I would divide by negative 3. Well, inequalities are solved the same way. I am going to divide by negative 3 on both sides of the inequality. Here's the difference. With an inequality, if I divide or multiply by a negative number across it, which means if I do it to one side, I have to do it to the other. That means across, okay? If I multiply or divide by a negative, then this inequality sign, which is greater than right now, has to become less than and be negative 5, okay? So let me write it over here just a little bit because I can see that little spot in the video. So you can see it right there. If I divide by negative 3 and divide by negative 3, then I must flip this inequality sign to this direction, and it becomes x is less than negative 5. Okay? And that's if I multiply or divide across the inequality sign. Remember, in equation, what we do to one side, we must do to the other. So inequality is the same idea. I can add or subtract across. I can multiply or divide across, right? But if I do it by a negative, not my answer is negative, but if I multiply or divide by a negative across it, then I must flip the inequality sign, okay? Those are kind of the pre-teach items for this unit. And now, flip up to, or turn the page and just go to the front page. I'm going to scroll up there. All right, it says Alan's scouting troop is selling popcorn to earn money for an upcoming camping trip, not for any upcoming camping trip, for a upcoming camping trip. Each camper starts with a credit of $25 towards his sales, and each box of popcorn sells for $3.75. Okay, easy enough. Identify the independent and dependent quantities for this problem situation. Well, I know my independent here is going to be the number of boxes sold. And what is it boxes of? Popcorn, obviously. That's what we're dealing with. And my dependent is going to be total sales. I'm trying to find my sales, right? Write a function in terms of f of b to show Alan's total sales as a function of the number of boxes of popcorn he sells. So I want to write a function, okay? Well, that just means an equation, right? I'm going to write an equation. In this case, an equation of f of b. So I know that this is f of b must be equal to. Now, I know I start with a credit of $25 towards the sales, and each box of popcorn is $3.75. I know my independent is number of boxes. So I know if I start with a credit of 25, and then I make $3.75 per box, that would be my equation. Now, I have it written like this. I could write it another way as well, and that would be f of b equals, and instead of 375 b behind the 25, I could write it 3.75 b plus 25. Now the reason why I can rewrite it that way is it's in y equals mx plus b form. Instead of f of b, I would simply write y, and this would be y equals my mx and my b term. Both of these are correct though. All right? So, what is the rate of change and what does it represent in this problem situation? Well, remember, rate of change is equal to slope, right? And in this case, what is my slope? Well, it's 375. And what is that equal to? What does that represent in this case? Well, it represents my profit per box is sold. So profit per box sold, right? It's my sales per box. It's my sales per box. Okay? Now, what is the y-intercept and what does it represent in this problem situation? Well, my y-intercept is 25. So remember, my y-intercept is when x is 0, my y is a value, so that's 0, 25. That's my y-intercept. And what does it represent? Well, it represents how much sales I have at the starting point. Well, they're giving us a credit of $25. So this is my starting sales amount, right? It's my starting sales because I'm trying to find total sales. So this is my starting amount. All right. So remember this function right here, 375b plus 25, all right? Okay, I'm going to scroll down and erase. Now remember, you can pause this at any point if I get going too fast. I'm just going to try to go a little bit quick because I'm already at 9 minutes right now, and we're barely to the bottom of the first page, so you know, if I don't keep going, it's not, it's going to be 35, 40 minutes, and I know you don't want to watch a video for 35, 40 minutes, so I'm going to try to keep it to 30. All right? So it says we can also analyze the function represented on the graph using an oval and or a box, which allows you to represent the total cells of specific intervals. For example, the oval here represents all the number of boxes Alan must sell to earn at least $1,600. What it's basically referring to is this oval right here is representing the number of boxes, which is my x-axis. So anything after this dot right here sold this way is going to be more than $1,600 in sales. Okay? Now it says the box represents all the number of boxes Alan must sell to earn less than $1,600. So this box inside here, and there's a box right here, and you can see that on your nose. Basically, anything from this point going this direction means it's the number of boxes that he would sell and not make $1,600 in sales. All right, so it says, use the graph to determine how many boxes Alan must sell to earn at least $925. At least. Okay, so that means he's got to make a minimum of $925. So at least means he's got to be greater than or equal to. That's the minimum amount. So we know he wants to be greater than or equal to $925 in sales. Okay? So, and that's dollars in sales, so that's not actual boxes. So write your answer as an inequality and graph the inequality on a number line. Alright, so find 925 on the y-axis, which I did. I'm going to go across, and I'm going to go across until I find the line. Boom, I found it. Now, at least means greater than or equal to, so I know it's a closed circle. We just covered that. Oh, we haven't covered that yet. We'll cover that here in just a little bit. We'll talk about it here in a second. So, I'm going to close that circle. So, where is that at least to? Well, it corresponds with 240. So, I know from 240 or beyond, I'm going to be greater than or equal to 925. So I know that it's the number of boxes sold must be greater than or equal to 240. Okay? Must be greater than or equal to 240. Now, what is the number of boxes sold? What is representing that? Well, it's B. So I know that B must be greater than or equal to 240. Okay? So B must be greater than or equal to 240. So let's graph that. Well, if I have on the graph, I could go 220, 230, 240, 250, 260, 270. On the graph, I just want to represent where I know where 240 is and I can look at it being bigger than. Well, bigger than 240. It's at least, so I'm going to use closed circle. Remember I told you I would talk about that here in a second. And I want to be bigger than that. So I'm going to go this direction because my numbers are getting bigger. Now, one of the reasons and one of the tricks that you'll find with doing this is that if you always have your variable on the left-hand side, always on the left-hand side, wherever it is, wherever the arrow is going is the direction I graph. Meaning that if I made that an arrow, I know my line is going that direction. If it happened to be B is less than 240, if I made an arrow, it would be going that direction. That's one of the tricks to this. Okay? It's one of the reasons why we want it on the left-hand side. It makes graphing much easier. All right. Now, the second part of this says use the graph to determine how many boxes Alan must sell to earn less than $2,050. Well, $2,050 is up here. I want to be less than that. It doesn't say equal to. Doesn't say, $2,050 or below, which means on that number. So I'm not to that number, but right up to it. I'm going to use an open circle. Remember, I told you what I'm going to refer to open circle and closed circles here in just a little bit. Okay? So open circle to this. So I know that anything below 250 is how many boxes I can sell, or 2,050. Any number of boxes on this x-axis below or to the left of this line, meaning this direction. Well, if I look at that, that number happens to be, what is this? Going up by 60, so 480. So this is going to be 540. So I know that B has to be less than 540. Now notice it doesn't have an equal to bar because it's less than $250 or $2,050. I keep saying $250. $2,050. So I'm going to be less than 540, and I'm going to graph that direction. So let's go 520, 530, 540, 550, 560, 570. I'm just counting by tens, make it easier. I'm going to find 540. I'm going to use an open circle, and I'm coming this direction. Now, I told you what that open circle and closed circle is going to be. So I'm going to go ahead and look at letter G right now for you, okay? And remember, pause. If I get going too fast, just pause it, all right? So letter G says, explain the difference between the open circle and the closed circle on the number line. Now notice, I used a closed circle there and an open circle there. Here's where it is. If I have an open circle is just with greater than or less than. That's it. Because it's up to that value but not including it, so it's an open circle. Okay, so up to but not including, open circle. That is less than or greater than. A closed circle is for when I have a greater than or equal to or a less than or equal to. That's what it's for. And I'm going to get rid of this other stuff so you can see that. So this is letter G right there. So I have an open circle for greater than or less than, and I have a closed circle for greater than or equal to, or my less than or equal to. All right. Questions? Ask. You'll see me actually when you get back from, Thanksgiving break and on that Monday. And we'll go over some of this again on that Monday. By the way, remember the song lyric. I have 3 jacks and a pair of 9s. 3 jacks and a pair of 9s. It is a song lyric. More information later. All right, turn the page. Letter G says another way to determine the solution set of an inequality is to solve it algebraically. All right, so in order to earn a $50 gift card, Alan's total sales must be at least $1,100. What did that just tell me? Well, in order to win a prize, and earn a prize. Okay, well this is a prize. This isn't part of an equation. This is something I get if I do something, right? So this is like kind of this white noise. It's there to confuse you. It's there to get you to do something with it, but it's just there. It's background, okay? It's just background noise. Don't fall in this trap. The comment, Alan's total sales must be at least $1,100. Oh, what is that saying? Well, that's saying total sales greater than or equal to 1,100. Total sales greater than or equal to 1,100. That's what it's saying, okay? Now it says, write and solve an inequality to determine the number of boxes Alan needs to sell. Well, the question is, do we have a function already? Do we have a function already? Do we have a function in place already to find out total sales? Yeah, we do. And I'm going to try to get it to where I'm out of that blind spot. So, what is my function? Well, my function happens to be 3.75b plus 25. What does total sales have to be greater than? What does be greater than or equal to? 1,100. I'm just solving a simple equation. This is a two-stepper. Subtract 25 from both. That's 1,075. Divide by 375. B is greater than or equal to, and get your calculator. Here we go. Let's figure it out, calculator. What do we got? What do we got? What do we got? 286.6. Come up with 286.6 repeating. So, how many boxes does Alan have to sell to be greater than or equal to 1100? Well, it's not 286.6. I can't sell a 0.6 of a box. So he's going to have to sell 287 boxes. All right. What is the greatest number of boxes Alan could sell and not reach a goal of 600? I'll give you a second. Think about setting that up. What do you think? Well, I think it's going to be total sales less than 600. Because it's not reach a goal of 600, which means I'm getting right up to it, but I'm not getting there, so I've got to be just less than. What's my function to reach total sales? What's 375B plus 25 and less than 600? Subtract 25 from both. And 375B is less than 575. Divide by 375. Divide by 375. And B is less than or equal to, put it into your calculator. I come up with 153.3 repeating. Hopefully that's what you get. If that's the case, how many can he sell? Well, he can't sell 0.3. Can I round up? No, because I want to be less than. So the number of boxes he can sell is 153. All right. Make sure you pause if you need to. If I'm going too fast for you, just pause, get through it, and then keep going. All right. Here we go. The next one says, Alan's camping troop hikes down from the campsite at an elevation of 4,800 feet to the bottom of the mountain. So they're up on a mountain of 4,800 feet, 4,800 feet up in the air. They're hiking down. They hike down at a rate of 20 feet per minute. Big word there for us. We should know what that means. We should know what it means because it indicates our independent, which is time. In this case, it's going to be in minutes. It gives us our dependent, which is right in front of it, which is height. We're going to measure that in what? You got it, feet. Write a function, h of m, to show the troop's elevation as a function of time in minutes. All right, so in terms of h of m, so h of m instead of y equals, where did I start? Well, I started at 4,800. How fast am I coming? Down or up? That's right, down, which means it's negative. And I'm decreasing at a rate of 20 feet per minute, so negative 20 m. Now, can I rewrite that? Oh, yes, I can. H of m equals negative 20 m plus 4,800. That gets it in y equals mx plus b form. Remember, either one of these are both correct. Okay, they're both correct. One's just in y equals mx plus b form. That's it. Either one of them works. Okay. What is the rate of change and what does it represent in this problem situation? Well, remember, rate of change is slope, right? Is slope. In this case, it happens to be negative 20. And what does it represent? The rate at which they are descending, going down per minute. The feet per minute. It's their descent rate. Okay? What is the y-intercept? Well, my y-intercept is at 0, 4,800. What does it represent? The starting point. How high they were on the mountain. How high? They were at 4,800 feet. They want to come down, right? Okay. So, the next question. What is the x-intercept and what does it represent in this problem situation? What is the x-intercept? Remember, x-intercept, and I'm going to come up here. I'm going to come up here so you can see it over here. My x-intercept is always x. I'm solving for x when y is 0. Right? When y is 0. So what do I do? If this is my function right here, and I want to know my x-intercept, which means y has to be 0, I want to find out how much time it took to get off the mountain. So what do? Some of you are correct. I'm going to plug a 0 into, or for h of m, or y, and I'm going to solve for m. I said some of you because I think some of you probably didn't answer. You just sat there and go, he's going to just give me the answer. Remember, I'm trying to get you to think a little bit here. So, I'm solving for m. Now, I can move 4,800 to this side or I can move 20 to this side. It doesn't matter. Remember, I'm a positive variable to divide by kind of guy, and I always like them on the left-hand side, so you know what I'm going to do. I'm going to move the 20 in to the other side. And that gives me 20m equals 4,800. I'm going to divide by 20, and m is going to be equal to, what do you get when you divide 4,800 by 20? You should get 240. Well, that's 240 minutes. How long is that? You're right. It's 4 hours. So it took them 4 hours to get off the mountain. How would I write this as a solution? Well, I know it's 240 for time, my independent, my m, and my y is 0. I didn't make a very good 0 there. But my y is 0. That's how I write it. All right. Questions on that one? We're about 27 minutes, so we're actually doing pretty well. Remember, pause if you need to. Oh, by the way, that song lyric again. I have 3 jacks and a pair of 9s. All right, turn the page, which I have already done. I've slid it up. You'll notice we're on the last page now. So, rocking and rolling, getting through this. All right. The next one says, the graph below represents the troops' elevation as a function of time. Use the graph, and make sure you can see the graph here. Use the graph to determine how many minutes have passed if the troop is below 3,200 feet. Draw an oval on the graph to represent the solution, then write your answer as an inequality. All right. Past 3,200 feet, which means I need to be at 3,200 feet or below, right? So, and really, it's below 3,200. So I'm going to find 3,200 on my y-axis. Well, it goes 3,000, 3,500. So I'm not quite half. I'm going to go this direction. I'm going to draw an open circle. To symbolize I don't want to be equal to that, but I know that that's my bare minimum, right? That I want to be below that, which means I've got to be greater than that, right? Now, it says draw an oval on the graph to represent the solution. What it means is that anything past this is going to be below. Anything past this point on the x-axis going this direction is below 3,200. And the reason why is that we're going down, descending. So I know if this is the spot of 3,200 on my x-axis, then I know that anything past that is below 3,200. So they want the oval to be right there. Okay? And all that represent is on the x-axis. Everything included on this x-axis is included as a possible time to be below 3,200 feet. So, What is our guess? Well, if we look at this, I know that 90 is right here because it goes 60, one line, 120 on the next line. So I know that this is 90. So I know that somewhere before 90 minutes. So I know my guess, because it really says write your answer as an inequality. So I'm guessing, based on the graph, because it's not precise here, it doesn't line up perfectly, that my minutes is going to be greater than, I'm going to say roughly 75 to 80 minutes. Okay? All I'm doing is making a guess, right? Educated guess based on the graph that anywhere from 75 minutes or above, I'm going to be greater to be below 3,200 feet. Everybody understand that? Okay, so this is just a guess. Okay, educated guess, because now we're going to find it algebraically. Okay, we're going to find it algebraically. It says, write and solve an inequality to verify the solution you interpreted from the graph. What happens when both sides of the inequality are multiplied or divided by a negative number? I think we've already dealt with that, but that's a big one, right? That's a big one. Okay, so here we go. Do I have a function already? Well, yeah. I have this negative 20m plus 4,800. And what do I want to be less than or below? I want to be below 3,200 feet. So I'm going to be greater than, right? Sorry, less than 3,200 feet. I know my minutes are going to be greater than, but I'm going to be less than or below 3,200 feet. So let's solve. Easiest thing, take the 4,800. So I should get negative 20m is less than negative 1,600. Notice I subtracted across and didn't flip my inequality. Remember, I only flip the inequality when I divide or multiply across the inequality. I can add or subtract across it and it doesn't affect it, okay? Now, I have a negative 20m less than a negative 1,600. Well, can time be negative? No. That's one of the reasons why I know that when I divide by negative 20 and negative 20, I'm going to have to be greater than, right? Because I can't be less than 80 minutes. We've already looked at this and said I have to be greater than one of these values. Well, 1,600 divided by 20, I'm dividing by a negative across the inequality, meaning I divided by a negative here and I divided by a negative here. So therefore, this becomes a greater than sign. Less than becomes greater than. And there it is. So I know in order to be below 3,200 feet that it will take me more than 80 minutes. Okay? And in this case, to be exactly 3,200, it would be greater than or equal to 80, right? But since it's below, I'm just going to be greater than 80. Make sense? All right. Go to the bottom. We have 3 problems left, just actual algebraic kind of problems. First one, making sure which one is, that one's in the spot, so we'll figure out how to get that one off to the side. So the first one, negative 2/3 x greater than or equal to 7. Well, remember, if I have a denominator, how do I get rid of it? That's right. I multiply by the common denominator, both sides. Okay? So I want to multiply both sides by 3. Now, could you have multiplied by its reciprocal, which would have been 3/2? Yes, you can do that. And I'm fine with that. I'm a common denominator guy. Okay? So for me, multiplying both sides by 3, well, on this side, 3 times negative 2 divided by 3 gives me just negative 2x. Okay, so 3 times negative 2 divided by 3. Remember, you can put it in a calculator if you can't see it. The rest of us can see the 3's cancel out, just leaving me the negative 2. Okay, I multiplied by a positive, so I don't touch the inequality. 7 times 3, 21. Now, divide by negative 2, divide by negative 2. X, since I divided across the inequality, what I do to one side, I must do to the other. Since I am doing a negative on both sides, then my inequality switch, which means x is less than or equal to. In this case, it's a negative 10.5. Now, with the equal to bar, I know it's a closed circle with the equal to bar. So let's do this. Negative 12, negative 11, negative 10, negative 9, negative 8, negative 7. Just labeled my graph at 10.5. Halfway, closed circle, less than, which means my numbers are getting smaller, less than, smaller. So my graph goes this direction. All right, letter B. This one's trying to trick you, okay? It's 32 greater than 23 minus x, okay? It's trying to trick you. You're going to have to, or you're going to want to put the variable on the left-hand side at some point, okay? I may do it at the very beginning, guy, not at the end. Because if you ever have negatives involved, then you're switching it and switching it again, and you're going to run into issues, okay? I don't like graphing with a variable on the right-hand side. It gets confusing, especially if you're already confused, okay? So I'm going to switch this right now. And what I mean by that is it's 32 greater than 23 minus x. So I'm literally just going to write 23 minus x and 32. All I did was put them on the other sides. That's it. Okay? If it was an equal sign, it's pretty easy. It's still easy here. I just got to pay more attention. It is opened up to the 32. You're going to see it says 32 greater than 23 minus x, right? That's what it says up here. So I'm going to make sure it's open to the 32. Open to the 32. Okay? To me, that's the easiest way to start with a variable on the right-hand side. Okay? I always want variables on the left-hand side, especially when I go to graph. All right, here we go. Negative 23, subtract them. Notice I have a negative x less than 9. I did not flip the inequality because I subtracted. I did not divide or multiply. Remember, I only flip the inequality if I divide or multiply by a negative number. Negative x less than 9. I can't be a negative x, so I must divide by negative 1, divide by negative 1, so x is now greater than a negative 9. Greater than negative 9. That means getting bigger. So negative 11, negative 10, negative 9, negative 8, negative 7, negative 6. Greater than, no equal to bar. So open circle, going greater, getting bigger, greater, getting bigger. I could draw an arrow. Notice that I draw the arrow, can go this direction. Boom, ready to go. Okay, last one. Distribute the 2 with the x and the 6. So 2 distribute with the x is 2x. 2 distribute with the 6 is 12, less than 10. Subtract 12 from both sides. 2x less than negative 2. Divide by 2, and x is less than negative 1. Now notice, I did not flip the inequality again because I divided by a positive. Even though my answer is negative, that doesn't matter. It's only divide or multiply by a negative across it. So I am x is less than negative 1. So less than -1, so let's go -3, -2, -1, 0, 1, and 2. Less than, so open circle. I'm less than. I'm going to rewrite this so you can see it. If I make this an arrow, I'm going that direction. And lo and behold, I'm done. All right, that is your notes. I kept telling you that the lyric, here it is once again. I have 3 jacks and a pair of 9s. If you can find the name of the song and the artist of that song, so name of it and the artist, it will come to help you. It will help you later on. Have a great Monday. Have a great Thanksgiving break. Look forward to seeing you on Monday. Ask any questions if you have them. I will be here on Tuesday. Thanks.